Good morning. Just a hopefully not too long of a lesson on solving systems of linear equations using substitution. Probably my very favorite way to solve them. It works almost no matter what. So let's take a look. Now, we're going to start with the idea of evaluating equations because you already knew how to do that. And carry that forward into how can I solve with substitution. Okay. So our big idea is we're going to solve for one of the variables. Okay, choose the most obvious or the easiest. Don't make this more complicated than you need to. Then we're going to substitute an expression or a value to find the value of the second variable. Then use the value of one to find the value of the other. It will make more sense as we do it, I promise. But let's just start with what you already know. You already know that if we have a nice linear equation like this, y equals 2x plus 7, and I tell you that x equals 2, you can evaluate this expression and tell me what y equals. We've done this before. So y equals 2x plus 7. But I said that x equals 2. So I'm going to rewrite this. Y equals 2 times 2 plus 7. Because instead of x, I put in the value that it's worth. Y equals 4 plus 7. And I ran out of room, so I'll just go over this way. Y equals 11. Okay, so now you know x equals 2 and y equals 11. You have a solution. Okay. Now, what happens when we have systems of equations, which we learned to define previously? Here we have two equations. Both equations have an x and a y, so it's a system of equations. Okay. The thing I want you to notice, y equals 3x, y is isolated. If you already have one variable isolated, use that to your advantage. Okay? So we already know that y equals 3x. So 2x plus y equals 15. But I can't solve an equation with two variables in it, Mrs. Atkinson. No, you can't. But you know what y equals. So since you know what y equals, you're just going to put that in. 2x plus 3x equals 15. Now you're going to combine like terms. 2x plus 3x is 5x. 5x equals 15. 5 times x equals 15. Well, so then the inverse operation to isolate x would be divide by 5. Okay, these cancel each other out. X equals, well, 15 divided by 5 is 3. So x equals 3. And I like to circle these in my work to make them stand out. So now I know what x equals. I'm going to take that information, and now I'm going to write this equation A. So I'll mark these A and B. So I used B first. Now I'm going to use A. Y equals 3x. Well, I know what x equals now. So I could write y equals 3 times 3. Y equals 9. Circle that. And my answer, my solution, just like we talked about when we talked about what a system of equation is, 3, 9. X, Y, right? So that's how you know how to solve this. If I graph these lines, they would intersect at this point on the graph, 3, 9. All right, let's try another one that's got an extra step in it, we'll say. It's not complicated, but an extra step. Okay, once again, I'm going to notice that in y equals 3x plus 1, oh, we love this format. It's magically fantabulous. Okay, y is isolated. So we're going to want to use that one to be the substitute, the thing we put in instead. So again, I'm going to kind of label my equations just so it's easier for you to follow along. Okay. So since this one's already isolated, I'm going to use that piece of information right there. X minus 3y equals 1. We know what y equals. So x minus 3 times 3x plus 1 equals 1. Now, you're going to have to use the distributive property. X, negative 3 times times 3x is negative 9x. Negative 3 times 1, negative 3. Okay? You distributed this to everything in the parentheses. Still equals 1. That hasn't changed. Now I combine like terms. I had 1 xylophone. The kindergartners took away 9 xylophones. I am negative 8 xylophones. Minus 3 equals 1. Okay, and we continue to solve what is now a very standard linear equation. Use inverse operations to continue to isolate x. X equals negative 1/2. Okay. I have to move my dot camera just a little bit for you. There we go. So we have a value now for x. So now I'm going to take equation A over here and write it down. Y equals 3x plus 1. Well, now I know what x equals. So I have to substitute that in. Y equals 3 times negative 1/2 plus 1. Okay. Y equals negative 3 over 2 plus 1. Okay. Now, you guys also know, and I'm going to write this step because it's what's happening in my thinking, that this is negative 1.5 plus 1. So if I owe you $1.50, $1.50, and I pay you back 1, y is still negative 1/2. Okay, so there's our solution to y. And our answer, the thing we would type into an answer box, we'll call it, x, negative 1/2, y, negative 1/2, parenthesis, there's your coordinate pair that's the solution to this system of equations. Now, I purposely picked one that had fractions in it because they're going to come up. And if we can practice together and take notes together with some of the more challenging problems, you'll be better off in the long run. I cannot wait to see you in class again. I'm so proud of you for sticking with this, copying these down. Do your homework. Come to class with any questions. Cannot wait to see you again.